Welcome back, guys. This is part 3 of our C programming tutorial video series. In this part of the video, I'm going to tell you how to store data in a program, and more specifically in a C program. In this part of the video, you're going to learn about the terms like variables, data types, keywords, assignment, declaration, and initialization. You might be thinking I'm trying to put a lots of stuff inside the same video. But this is not the case actually. See, all these different terms, they are more or less related to the same concept of storing data in a program. Okay, so okay, let me like first briefly explain you what I mean by storing data, and then how these different terms are related to this, storing data concept. Okay, then let's begin. Say, okay, let me start with an analogy. Say, for example, I give you, some sugar. Okay, I give you some sugar, and then your task is like you have to store the sugar somewhere. Okay, so when we have to store something like sugar, then what we do is typically what we do, we go to the market, we bring a container, we buy a container if it is not already with us, and then what we do is we put the sugar inside that container. That's how we store stuffs like sugar or salt or like that. That's typically we do, right? And say for example, again, we have to store, say, some liquid, say for example oil. In that case, again more or less we'll be doing the same thing. Say we will go to the market, we will bring a specific type of container, and then inside that container we'll be storing our oil or that liquid, whatever it is. Okay, so for example, this is oil. And let me give you another example. Maybe say for example, you have to store say a pair of boots you have, and then you want to keep it like in a safe way, maybe in slightly. Okay, that is, you have a pair of shoes or you have a pair of boots, and then you have to store this pair of boots somewhere. Then what you do is you go to the market, and then you bring a container that is actually a box, say, in our real world situation, and inside that box you can put your you can put your shoes, or you can put your these boots there, right? uh, so boots usually they come in the package like this, somehow something like this way they store. Okay, I'm just trying it. Okay. Anyhow, I guess you people got the point. Now, see here, we have to store sugar. Then what we did is we just bought a container, and then inside that container we stored the sugar. We have to store liquid. Then we from the market we bring a specific, slightly specialized type of container for liquid, and we store the oil there. Suppose we have to store a pair of boots. Then again, slightly specialized based on the need, we bring a box from the market, and inside that we can put our shoes safely. Okay, now this is the real world situation. Now the same analogy now you can use when we mean by storing data in a program. Now see, in a program also, whenever you have to store data in a program, whenever you have to store data, what is the first thing that the program should do is it should first, to for that data it should get a container. See here, the way first we want to store something means first we get a container, and then inside that container we store the data. We store the things. Similarly, in programming world, whenever we have to store data, then in a program, then what we have to do is in that program, first thing that we have to do is we have to get a container, and inside that container we can store the data. Now the question is now here, okay, in real world situation, we know from where to get the container, right? We simply can go to the market, or we can search it online and we can buy it from the market, right? But in case of a program, what happens? Like from where it gets the container. So in programming world, these containers are all these containers are actually there in the memory of the computer that we call as the RAM of the computer. Okay, so whenever you are executing a program, whatever it is the data that the program is manipulating or the program is trying to access, all those data must be there at some point of time in the RAM of the computer. That you should realize. No matter what program you are executing, no matter whether you are executing a C program written by you, or you are executing a, say for example, a software like say Microsoft Word or Microsoft Excel, or say Paint, or say Adobe Photoshop, or say a web browser. In all these cases, you are actually executing some programs, and those programs need to manipulate data there. Okay, so all those programs, they also have to store their data in the RAM so that they can process on those data. Got the point? So that way, whenever you are writing a C program, then if in your program you have to store some data, then somehow from the program you should be able to create a container in the RAM, and then only you'll be able to store the data there. Now, don't worry about the process. I mean, it is a very straightforward. You will be knowing like how easy it is in from a C program, or in fact from any programming language, to create some container in the RAM. In a moment, you'll be seeing it. But before that, slightly, let me tell you the background story also. Okay, now we know that thing. Okay, the first we have to store data. I mean, if we have to store data, then first thing that we have to do is we have to get a container, and then we can store the data inside that container. That is the first similarity of storing data in a program with the analogy of storing things in real world. That is the first similarity. That is, we need to get a container. That's the first one, right? Now, the second similarity is also there, and you see what is that second similarity? Can you see that? See here, to store different types of things, we get usually or typically we use different types of container. That's why I gave you these three examples. So in case of sugar, we use the container something like this. I mean, you might be saying, okay, I can use certainly a bottle also here, or like a container which looks very much similar to the container where we store oil. Yeah, certainly, but just for the sake of an example, and considering the most considering the general way of doing it, and how people typically store these things, I'm saying you, like say for sugar you'll be using a different type of container. For oil you'll be using a different type of container. To store these pair of shoes, you'll be using a different type of container, right? More or less, it is the fact, isn't it? Based on the thing that you want to store, you will be using a container, or a suitable container. Now this similarity is there in programming world also. Okay, so what is that, what I mean by this similarity? See, to store, first thing is, to store data you need a container, and the second thing is, based on the type of the based on the type of the data, based on the type of the based on the type of the data, your type of container varies. Type of container varies. Okay, that is another similarity you can think of with this real world analogy example. Now, these are two things we learned, right? Need a container in the RAM, and also based on the type of the data, the container varies actually. Now, the next question is, okay, then what we mean by the type of the data in a program, or more specifically in a C program? To understand this, now let's see some different types of data. Say, for example, you are writing a program that needs to, ask the user to enter their age. Okay, so the age of a person, age of a person. Now, the age of a person could be, say, for example, 17 years old, or maybe 71 years old, or maybe 35, or maybe 51, like that, right? Now see, all these different numbers like 17, 6, 71, 35, and 51, all these numbers, this type of data, they do not come with a decimal point. What I mean is, for example, a person usually doesn't say like my age is 71.30 years, isn't it? So there are some data where the decimal part is not important, or the decimal part is, the decimal part doesn't exist. Say, for example, the age of a person. So these type of data is recognized in a C program by a specific type, and that type is called as the integer type of data. It means what? Whenever you want to store, suppose for example, the number 17, what basically you are doing is you are actually storing a integer type data. You have to store a integer type of data in the RAM. Whenever you have to store the number, say for example -71, in that case also you have to use a integer type of data in the RAM. Now see, from here you should realize that, okay, it means what? The integer type of data could be both positive as well as negative. This sign is there, I mean, in integer type of data, both positive and negative numbers could be an integer. But what it cannot have, or what a integer type data doesn't have, it doesn't have the decimal part. Okay, even a 17 point, if you want to store, say for example 17.0, you might be thinking the value of 17.0 is same as the value of 17. But then also, if you want to store it like explicitly like 17.0, in that case you will not be able to, the type of this data will not be an integer type of data, it will be a different type of data. And what will be that different type of data? Yeah, I'm just telling you. Now say, just consider, say, I guess people got like what could be an integer type of data. These are numbers without any decimal part, both positive and negative are possible. Now, let's say now, let's talk about the average marks obtained by a student, say. What are the possible values? What could be the possible values? The values could be, say, for example, one student got 71.50%, and the other student got, say, for example, say 71.01, and other one got, say, for example, 70.99. Now you see, in this type of data, this decimal part exists and they are important. We know, like from our experience, that at least specifically in average marks, if someone got 71.50, it is different. It could be quite different than someone who got 71.01, and it could be quite different from someone then who got 70.99. Right, these numbers, like they have clearly differences. Right, now see this decimal part, like if the data that you are trying to store in a program has this decimal part, this fractional part, like 71.50, or maybe this 17.0, when you are trying to store some numbers which have this decimal part, then it means what type of data you are trying to store in the computer? You're trying to store a floating point, or floating type of data, in your computer or in your RAM, floating point data in your RAM or in your computer. So all these data, all these numbers, they are actually of type floating point. And the way integers could be both positive and negatives, here also, these floating point numbers could be both positive and negative. It means if you want to store, say, -17.0, then also the type of this data is floating point data. You got the point? Okay, then there is another one. I mean, in fact, two are there, but okay, let me first talk about this third one. There is, okay, your data could be like this or like this. Say, for example, now talk about, say the gender of a person. Your program is trying to, your program is collecting the gender of a person, say. Okay, and in that case it just accepts only one letter. It could be either a person can come and say, okay, gender is either M or maybe F, or maybe say transgender T. Okay, so in that case, see here the type of the data in this case, they are only one single letter, like M or maybe F or maybe T, like that. Okay, so if it is the case, then the type of this data, in C programming world, we'll be calling as the type of these pieces of data. They are like called as character type of data. I'm just introducing you to the basic data types available in C programming, or what, in other words, that what are the basic types of data a C program recognize. Okay, so in a C program, these type of data are called integer type data. This type of data are called floating point data. This type of data are called character type data. And there is another type of data in C programming that is called as double type data. Now, these double type data, for the time being, you can think of they are almost equal to floating point data, float data, only in the sense that their size is, like bigger. So you can say like floating point data, but of bigger size. So that much only I'll be telling you about double type data in this part of the video, but certainly in my coming videos, I'll be telling you what are the accurate difference between these double data type and float data type. But before that, what I want you people is to get comfortable with the things, like let them first I want you people to use these basic simple data types first, and then you can get into the details of, okay, what exactly are the differences of these different types of data, or more specifically, like say, of these two very similar types of data. But for the time being, what will be enough for you to know is that double is also a basic data type in C programming language. But the thing is, they are very much similar to float. Only difference is that float double is actually the same float data type you can think of, but in a bigger size. Okay, so if it is a bigger size floating point number, then it is a double data type. So these are the four different types of data that a C program can, a C program recognizes. Okay. Now, if you think for a moment, like, and if you're following the video and if you think for a moment, okay, whatever I'm saying is true, but only can these only be the only types of data that we might want our program to handle? I mean, even in the general case? If you think for a moment, then you'll realize, okay, say for example, what if I want to accept the name of a person, name of a person? In that case, what will happen? So the name of a person is not like 15. You cannot write it in this way. The name of a person, you cannot write like 15.0. No, certainly not. And the name of a person, you cannot write like A, B, C, or D like that. I mean, you can, but that usually doesn't happen, right? Only one letter, and that is the name of a person. There might exist some names, but not generally, right? So what is a name then? A name is nothing but, say, for example, it could be like Mr. XXX. Certainly XXX is nobody's name, but here it could be, here at least I'm writing multiple letters there. Say, for example, say Mr. Say Raza. Like that. I just thought of this name. Or say, anything. Say Miss Pallu or something, whatever. Now, so if you see now, these name of a person, they are not like a number integer. They are not like a floating point number. They are not characters, a single character. Certainly, they are not. But what you can think of is they are a sequence of single characters. If you see these name, you can think of, okay, it is actually a collection of some single characters. See, M, R, space, all of them independently, they are some characters, and if you put all those characters together, they will form a name. Here also, M, R, then the space itself is again a character, so you can consider it R-A-J-A, like that. So this way, your name could be small name or your name could be a big name, but that way you'll be able to store a name in your computer program. I mean, how you'll be able to store a name? Somehow, if you know how to combine multiple, how to combine multiple character type data together, then you'll be knowing actually how to store names. So for that reason, there is no specific data type for this type of data. So if we want to store this type of data in the computer program, then the programming language certainly gives us ways through which we can combine these multiple characters and form this or can store this type of data. I'll be coming. This type of data are called as string. So this is quite an interesting and important topic in C programming language. But this topic we'll be discussing almost in the second half of this video series. But before that, we should know a lots of other basic and simple details about the programming language. Okay, so that way, so these are the type. I mean, now you at least have the idea, like, okay, if we have to store these names, certainly there are some ways there. Okay, based on these basic data types only, we will be able to store store some store data that looks like the name of a person, or it could be anything, say name of an organization, or maybe uh, um, the code of a person. Say, I mean, code of a person means in India that could be an Aadhaar card number. In US, maybe that is a, what number, that ISSN, not ISSN, what is that, personal personal identification number, or whatever. Some numbers will be there in different countries. So those things. So like maybe a roll number of a person, say for example CSB 21001, that is the roll number of a student. In that could be possibly a roll number of a student. So here you see, it is not a single character, it is a collection of characters. So these type of data we call as strings, but in C programming, we do not have a specific, dedicated data type to store these strings. So what we have to do is we have to rely upon the, the character data type, and and somehow by using some available feature of C programming language, we'll be able to combine them together to form a string. Those things, certainly, as I said, we'll be learning in our coming videos. That point, I guess, you people got. Now what we left with is, now then, okay, we are now, if we know, like, these basic datas now, the types of these. So what we have realized now is that, like, we have these four basic data types, like integer and this floating point number, and then these double type data, and then these character type data, right? These four basic data types are there in C programming language. Then certainly there are some other data types also. These are called as, like, there is something called as, again, I'm just referring to a future topic. These are called as the modifiers. Okay, modifiers. Using these, you can create different versions of these basic data types. But again, I'll be coming to that topic in some coming videos. But for the time being, let's now, since we have learned about these, basic four data types, let's now, try to see how we can store these basic data in a C program. Okay. Okay then. Now, okay, let's again just a few more things. Say for example, now we know that, like, at least we know as a human being or as a programmer that, okay, if we have to store this 9, then what type of container we need? We need an integer type of container. If we have to store -9, then we need similarly an integer type of container. If you have to store 51.002, we need a floating point type of container. If we have to store a single character, say A, then we need a character type of container, right? Now we know now how in a program then we specify these things. Okay, so these specifying these, like, okay, now we are ready, like, we are ready now how in a program we can create a container of a specific type. And how do you do that? We do that by making use of this declaration statement. I mean, something called as declaration. Now, it's just a term that is used to, to describe a particular process. The process of creating container in the RAM based on the type of the data is called as, the declaration statement. Okay, now what exactly it means? A declaration statement, the syntax of writing a declaration statement is usually like this. First, you have to specify the type of the data that you want to store inside the container. Then second, you have to specify a name to the container, container. Now see, in my example, somewhere I remember writing oil. Yes, now see, this is a label that you can put on the top of the container so that you know what data or what is the thing that is there inside this container. Putting a label, in real world, putting a label on a container is same as, like, in programming world, giving a name to a container. Okay, so in declaration statement, what are things that you have to do? First thing is you have to specify the type of the container, what type of data you want to store inside that container. And then second thing is that you have to also give a name to the container, mandatory. And after that, you have to put a semicolon. You have to put a semicolon. That is the general syntax of declaration statement. Declaration statement means what? It is like creating a. You can think it of in this way: creating a container in the RAM based on the type of data. Okay, so that is called as the declaration statement, and this is the general syntax of a declaration statement. Now see, the question is, this is just the formula. Now what could be an actual incarnation of this formula? First thing is this type. Here you cannot write anything. Actually, there are like some specific words are there that you can write. For the time being, we'll be using, say, we know the 4 basic data types, right? So if you want to store a integer type of data, then what you will be specifying is the type of the data you will be specifying as int in the way I have written here. Now see, when I say in the way I have written here, see, you remember in my previous video also I have said you that for this compiler, usually I'll be representing the compiler in this way, okay? For this compiler, you know what, like whatever the code that you write, say p1.c, that code goes through a compiler, and that compiler converts it to a machine level code, say for example p1.exe. That much you know, right? Now see, for this as I said in my previous video also, for this compiler, these a is completely different from these uppercase a is completely different from these lowercase a. I mean, the way T is different from P for us, the same way capital A is different from lowercase a for the compiler. It sees them. It doesn't know that this both of them, sorry, both of them are actually A's. Okay, it doesn't know that. Okay, so that way, if you write now integer and if you write integer, then certainly for the compiler, this int is different and this int is different. I guess you people got the point now. So the point is that the C compiler is case sensitive. It in the sense that if you write something in uppercase, that is completely different from if you write something in lowercase. It means case sensitive. Okay, I'm writing case sensitive. Sensitive. Remember this term. You'll be remembering it forever now, right? So that way, if it is case sensitive, it means writing int is different from writing int. So when I mean that you have to write the type, one possible words is writing int. Whenever you want to store a number, like an integer number, then what you will be doing is you will be specifying the type as integer, int. That's all. Not intger, not I in capital, in T, or not any variants of this word, exactly this word. Okay. And suppose now, okay, I'll come to this name of the container in a moment. Now suppose the other possible types are, let's first see them. Suppose now you want to store a floating point number. In that case, what word exactly you will be writing? You will be writing the word float, float, not in any other variation, not in any other form. Float means you have to write it exactly as it is. All of them are lowercase, float, not floating, not fl, not f in capital loat. So all these variations will not work. Reason, you know, right? Okay, so int, and then if you want to store a floating point number, you will be specifying the type as float. If you want to specify a double number, I mean a bigger floating point number in some sense, you will be using the keyword double, double, exactly as it is. If you want to store a character, then you will be using the type as char, exactly as it is. It is not like character or maybe ch, or maybe c is in capital and har. No, not all those different variations are allowed, only exactly char. Okay, so now what we realize is, okay, 4 data types we have seen, there are examples we have seen. Now that we are ready now to learn this declaration statement. Declaration is nothing but like creating a container in the RAM, and the syntax is type and the name of the container. For the type part, we already have learned, like, okay, if it is an integer that I want to store in the RAM, then I'll be writing the type as int. If it is a float, then I'll be writing the type as float, double, or character. These words you have to write as it is. I'll come to this point after some time, but yeah, for the time being, you just have to realize the fact that these words you have to write as it is. Okay, done. Now, what about this name to the container? Now, these names to the container, when you write, now here you have complete freedom, almost complete freedom. Okay, it means suppose you want to create a container in the RAM to store a number, integer number. Then you can do int, and then you can call the container by any name. That's what I mean by you have full freedom. Say you can call the container A, and after that, as part of the syntax, you'll be putting a semicolon at the end. So you are creating a container in the RAM whose name is A. These name part could be anything. Say, for example, in you need another container. See, you can create as many containers as you want. Obviously, it should be. I mean, as you know, the containers will be created in the RAM. So obviously, it cannot go beyond the size of the RAM. But as long as in the RAM you have space, you can create as many containers as you want from a program. So for example, you want to create another container and you can call it, say for example, container B, or you can call container bog, or you can give any meaningless name also, bog 129 5, Z, Z and T. This is also a container. This is the name of your container. So these names, the name of the container, whatever the name that you give, more or less you can keep anything as the name of a container. You got the point? Here, there is no restrictions like you have to write the name of the container exactly as it is, like BOZL21 for a specific purpose. No, it's not like that. No, this naming is completely programmer's choice, so they can keep any name they want. But yes, certainly in the latter part of the program, certainly these names will be used to refer to those containers. So obviously, logically, they have to use the same name to refer to the same container. Got it? Now, same way, now here also for floating point number, say you want to store a floating point number, you'll be writing the type as float, you'll be writing the name of a variable, say for example, jet, and you'll be putting a semicolon. Double, say P and semicolon. Character, say X and semicolon, like that. So these things are called, like, right, these particular statement, like type of the data, name of the, the container, and then the semicolon, all these three together. If you say, what we're doing here is basically we're asking the computer to create container in the RAM, and technically that thing is called as the declaration statement, or technically that thing is called as declaring a variable. Okay, now see this word is coming. What is a variable then? These are called as these variables. This Z is a variable, P is a variable, X is a variable, A is a variable, bog, this thing is a variable. So all these are, in general, they are called as variables. So what are variables basically? These variables are nothing but they are container in the RAM, isn't it? And they have some names there. Got the point? So see here, we learned like declaration means what? This thing is called writing, no, creating a container. The process of creating a container in this way is called a declaration statement. And this declaration statement, what does it do? It basically declares a variable. And what are these variables? These containers are called actually the variables. The containers that we create in the RAM to store data, those containers are technically called as variables. Okay. Okay, if now I guess I'm more or less ready to. Okay, now let's see some more details now in this way. Say for example, now let's check our understanding sort of. Okay, say for example, you have to store this number 9 in a computer program, in a C program. Okay, so what you will be doing then to store this number? The first thing is that in the RAM of the computer, you have to create some variable or container. So for that reason, since you want to store 9, what you'll be doing is, okay, first you will be creating a integer type container in the RAM. Let me represent it with the help of a box. And then you have to give it a name. Done. And after giving the name, like this is only the creation part, right? You have created a container in the RAM, and you called that container, you gave that container a name called A. Done. Then now the next part, you want to store the number 9. Okay, you have created this container because you wanted to store this number 9 there inside this container. So how you are going to store this 9 inside this container? It is straightforward. It is just like writing A is equal to 9, and you have to put a semicolon at the end of the instruction. Got the point? See what we do first. First, we create a container, and then inside this container, that creating a container is a complete independent statement. At least in this case, okay. Whenever you are writing this semicolon, it means that that is one instruction over, and the computer will execute these programs by instruction. That is, first thing is it will execute the first instruction that you write. Once this instruction is over, then it will go for the next instruction. So that way, here you see int a semicolon, it means that is one single complete instruction, and then a equal 9 semicolon, that is another one complete single instruction. So that way, what the computer will first do when you execute, suppose this program where these two lines are written, whenever the computer comes to execute this line, int a semicolon, it will immediately create a container of type integer in the RAM, and then it will give it a name and it will call it a. Done. That's all it will do. Once that statement is over, then what next it will do? It will go to the next instruction where you have written a equals 9. When you write a equals to 9, then yes, and then you realize like what it will do is it will store actually this number 9 inside the container. Got it? Okay. Now here, let me tell you one thing if I have not already said you. This RAM, although I have written it like a container and inside that I'm storing 9, but you see, you should realize that the RAM is nothing but, you can think of this RAM is actually a table, and where in each cell of the table you can store either a 0 or a 1. That is, whatever the data that you store inside a RAM, they will be stored in the form of they will be stored in their binary format. And when you create a container, basically what does it do is it just considers a set a certain number of bits together. These are called as your bits. Okay, a single cell will be called as a single bits. So it consider a certain number of bits together, and it calls those certain number of bits a single container. I'll come to this point. This point is important, like how many bits should be there inside a container. Okay, that thing is also important. But here, my point is that when I say it creates a container in the RAM, it means you should realize that, okay, it actually, like sort of books a set of, or a books a, like a collection of bits, conjugative bits, which are one after another. And combinedly together, those set of bits are given a name, and whatever it is the name that you give to the variable. So when we say like a equal to 19, we say that okay, we have stored 9 in the container a, but in reality the binary representation of 9 will be stored in the in the sequence of bits which are assigned the name a. You got the point? That is the real thing. But for our understanding, if we can say like, okay, we'll be using this notation, like it will create a container, and in that container it will store 9. But this is actually, in a deeper level, the things are more like this than this. Okay, now this thing, now what I already told you, like what is this declaration statement, you are clear about it, I guess. Now what is it? Declaring a variable. I mean, these declarations, they are actually creating variables. And what are those variables? These variables are nothing but these containers, and to which some names are given. These names are actually variables. These names are, so what is a variable? Basically, a variable is nothing but it is the name. See here, this p, x, z, these are variables. It means what? They are the names given to a particular container inside the RAM. Those are variables actually. Okay, so whenever you like now you see the term variable, you can think of, okay, it is nothing but it is just a container there in the RAM where you can store some data. And what type of data you can store inside that container? Whatever it is, the type of the variable. So for example, here a is a variable. The type of the variable a is integer. Okay. Then we just have here, we already know, like this is what? This is declaration. Now what is this then? What is the specific name of this particular instruction? The name of this type of instruction, you see, you can create as many different variables, and you can store. Say for example, you have to store 9.50 in your program. What will you do? Yes, you know now, right? So you will be first creating a container in the RAM, and you'll be giving it a name. Say for example, pq, p sorry pq. Okay, so it will In the RAM, it will create a container. It will call that container PQ. And you want to store 9.50 in PQ. So you'll be writing PQ equal to 9.50 and a semicolon. So 9.50 will be stored inside this container. So this is declaration we know. Now what is this? See here the similarity of these two statements. As the variable is on the left hand side, then this equal symbol, and then this value that you want to store on the right hand side, and then this semicolon. The variable is on the left hand side, then this equal symbol, then the number or the value that you want to store inside that variable is on the right hand side, and then terminated by this semicolon. So these type of or these instruction is called as the this is called as the assignment instruction. Okay, assignment. ASSIGNMENT, assignment statement. What basically assignment statements. Okay, statements. Now, what an assignment statement does, it stores a value in a variable. So whenever you are storing a value in a variable in this fashion, you are basically you are doing an assignment statement. You are assigning a value, you are assigning the value that you are writing on the right hand side, to a variable that you write on the left hand side. That is, you are storing a value to a variable. And that thing technically is called as the assignment statement. Got it? So first we create a variable, we declare a variable, then we do an assignment to store some values there in the variable. Now see the syntax of assignment variable. So what is the general syntax? If I ask you what is the general syntax of an assignment statement, you will be saying, okay, the general syntax is a variable on the left hand side equal to some value on the right hand side. This is the general syntax. Whatever it is, the right hand side value that you are writing, that will go as the value, as the content of that particular container. And this equal symbol is mandatory. And this equal symbol actually performs this equal symbol actually tells the computer, okay, you have to store the value on the right hand side on to the variable or inside the variable, whatever you have mentioned on the left hand side. So these instruction is called, or these type of statements are called as assignment statements. Clear, right? Okay. Now we know this thing, like whenever we have to store 9, right now at least we know it in two different steps. First, we have to create the container. Second, inside the created container, we'll be storing the value by making use of these assignment statements. Okay, great. We have learned most of the things. Then now let's now see. You can do now some shortcuts. So for example, you want to store this number again, number 9 in a computer program. Till now, what you know, you have this RAM, you have this RAM. So you want to store 9 means what? You have to create a container in the RAM. And how do you do that? It means what? When I say create a container in the RAM means you have to what? You have to declare a variable. That is the first and foremost thing that you have to do, because you have to create a container. And how do you do that? Declaring a variable. So for that reason, okay, since you want to store an integer data, you will be writing int is the type of the data, and you'll be giving a name to the variable. You'll be putting a semicolon, and then we have to store 9 there, so we'll be writing a is equal to 9. So it means we are doing this. First step, we are creating a container, giving it a name. Second step, we are storing 9 there. Now see, both these two statements, like if this is specifically called as declaration, and this is specifically called as assignment, right? Both these two statements you can combine in a single instruction like this. Integer a is equal to 9. Now when you do this, when you do both this declaration and assignment at the same time, it has a specific name then. This is called as initialization. Okay, when you are saying that you are initializing a variable, it means what you are doing basically is you are creating the variable, at the same time you are storing some value inside that variable. So whenever you write int a equal to 9, basically it will have the same effect in the RAM. Say what it will do is it will create a variable, it will call it a, immediately it will store 9 there. Got the point? Okay, so more or less, see here, these are the terms that I said to you at the beginning. You see how easy they are. Like, you know what is a variable, isn't it? Like, these are the names of the containers that you give in your program. Then you know what are data types. At least 4 basic data types you have seen. I'm sorry. Say, for example, the type of the number 59 is integer. The type of the number 59.50 is a floating point number. So those are different types of data. That's what we mean by data types. So there are four basic data types, at least you learned in this part of the video, like float, integer, double, and character. Then these keywords, I have not said anything about it, but you already have seen them. That's for sure. I'll be showing you in a moment. But before that, let's see this assignment. You know what is an assignment operation, right? Or an assignment statement. This type of thing whenever you are right, like a equal to 9 semicolon. Whenever you're making use of this equal symbol to store some value in a variable, that particular thing technically is called as, or that particular statement technically is called as assignment statement. You're assigning a value to a variable. So, okay, that also you then know. Then what is this declaration? You know what is a declaration. Declaration is nothing but creation of variables. And how do you do that? So, for example, you want to declare a variable of type integer. This is declaration, integer a. You know that, right? Okay, that also you learned. Then what is left? Initialization. Oh, you all know that too. So it means what? Whenever you do declaration and assignment in the same instruction, or in the same statement, then that is called as initialization. It means what? See, so you are doing here like, yeah, you want to store 9 in a variable, in a program. Then first you can create a variable, then you can do assignment to that variable, certainly. And another one shortcut is that you can create the variable and at the same time you can store the value there. And when you do both these two things together, it is called as initialization of a variable. Got it? The one thing left now, then the term like what is these keyword, what these keywords mean. Now keywords are, see, you have seen these keywords. When I said you see these type, in the type field, you have to write at least for the time being 4 types you have seen. So if you want to store an integer, then type you have to specify exactly as it is as integer, int. Here, the word you have to write exactly as it is, float. The word you have to write here, double. The word you have to write here, this character. These words, you see, these words you have to write as it is. It means what? These words they have specific meaning, meaning, meaning to whom? To the compiler. What I mean is, see, when the compiler sees this word integer, it knows what it knows, that it has to create a container of type integer in the RAM. But when it sees this word int, it doesn't mean anything for the compiler. Why? Because we know that C is a case-sensitive language. So for that reason, this capital INT doesn't have any meaning for the compiler. However, this word INT, it has a specific meaning for the compiler. And in the same way, all these different words like float and double and this character, they have specific meanings to the compiler. And you already know what are those specific meanings. Say, yeah, if you write int, it means the compiler has to, like you are instructing, okay, first create a container and give a name to that container, and whatever the name you specify here. And when it creates the container, what type of container it has to create? Whatever it is represented by, this type keyword here. Like if it is an int you are writing, it will create a integer type container. If you are writing float, it will create a float type container, double type container, character type container, like that. So you also have seen now what is a, what are these, different keywords. See, not only these 4 keywords are there in C programming language, there are like 32 keywords, but at least right now you know these 4 keywords. If someone asks you like what is a keyword, then you'll be saying, okay, these are words for which the compiler has some specific meaning. I mean, these words have specific meaning for the compiler. So if you say int to the compiler, it understands what it has to do. If you say float to the compiler, it understands what it has to do. So all these words that brings some meaning to the compiler, those words are called as the keywords. And there are 32 different keywords are there to represent, different things or concepts to the compiler. Okay, now you know what are keywords, how many of them are there, and at least you have seen till now 4 of them. Okay, okay. Now you see, don't get confused. The semicolon not a keyword, a is not a keyword, 9 is not a keyword, equal is not a keyword, int is a keyword, right? And which one is keyword here out of these two lines? This float is a keyword, right? Okay. Okay then, but we are sort of then ready to. We have seen most of the basic details then about a variable. Now we know all these different terms at least, right? If anyone asks you like what is a variable, you know what are data types, you know what are keywords, you know what are assignment, you know declaration, no, initialization, yes, you know that. Now theoretically, at least you know things. Now let's do it programmatically. Now how to do the things in a program. But before that, again, let me tell you some extra things. I didn't say you what are the exact difference of integer and float and double and character. But here it is the time now, I guess I can tell you one difference. Now see, when I say the container, okay, like you all these are actually keywords, isn't it? Integer is a keyword that instructs the compiler to create a integer type container in the RAM, that you understand by this time, right? Float is the keyword that instructs the compiler to create a float type keyword in the RAM. Double, similarly, double type keyword, and character means character type keyword. Now, what exactly a character type in a container, but what exactly this int type container is? At least in terms of their size, they are different. Now see, when it creates this integer, when this this keyword integer, say for example you are writing int a, you are creating a variable in this way, you are declaring a variable, so it will create a integer type container in the RAM and it will call it a. And what is the specification of integer type container? Now this considering this RAM as a table will be useful. So I said, like this RAM, you can think of another view of this RAM is it's a table. Okay, it's a table of what? It's a table of bits. Now, when you say a container, as I said, no, it considers a set of conjugative bits to represent the container. So, how many bits will be considered for a container? That is the question. Okay, and these number of bits. So the question is that how many bits in a container? I mean, to form a container, how many bits you need? Yes. So that information is hidden in this keyword. So if it is an integer type container, then the size of this container will be, the width of this container will be 16 bits. Based on the computer architecture, it could be 32 bits also. But for simplicity, like, okay, whenever it is a type integer type container, they are like, the width of the container is 16 bits. Whenever it is a character type container, it is the, say, character B. Whenever it is a character type container, the type of the width of the container, it will create a container in the RAM. And what will be the width of the container? It will be 8 bits. It means what? That container will occupy 8 consecutive bits in the RAM. Okay, and those 8 consecutive bits in the RAM will be given a name called B. And so you see here, these keywords like these data type keywords, they not only tell the compiler what type of data you are going to store inside a container, but also they instruct the compiler how many bits are to be reserved, or what should be the width of the container. So if it is a int you are writing, it means the container width will be 16 bits. If it is a character you are creating, if it is a character container you are creating, the width of that character container will be 8 bits. If it is a, say for example, float variable or a float container, then the width of that container will be, yes, see, 8, 16, and you can remember it that way also, say 32 bits. Okay, and if it is a double type container, if it is a double type container, say D, in that case, D will have the width 64 bits. It means what? Just following these things logically, you should be able to realize that the maximum value that you can store in a character type data is very small, because with 8 bits you can represent only at most 2 to the power what 2 to the power n minus 1, so 2 to the power 7 minus 1. if you store all these numbers as positive numbers, so that is the maximum value that you can store. I might come to this point with some details later on, I guess, right? But for the time being, you see, the size, if the size is small, it means you will be able to store less amount of data in the container. If the size is bigger, then certainly you will be able to store more amount of data in the container. That analogy will work for the time being, I guess. Okay. Now, but you should know, like, what are the sizes at least. Say whenever you write int, then it means the width is 16 bits. And again, sometimes it could be 16, 32 bits also based on the architecture. And if you write character B, it could be the size of the width is 8 bits, float means width is 32 bits, and double means the width is 64 bits. Those are some more details that I had to tell you. Now you know, right? Most of the things you know, I guess. Now whenever you write now, okay, if you now see some C code, you might be thinking, why am I not going to the actual typing program? Yes, but before that, I think if you listen to this video once, then you'll remember most of the things. I mean, the background things. Okay, but once you know the background things, then you can use these concepts to write programs actually. Okay, I'm just telling you the concepts now. Okay, now if you see a program where it is written like int a and then a is equal to 95, you know immediately more or less what happens, underlining, what happens behind the screen. What happens behind the screen? In the RAM, a container will be created. What will be the container of what will be the width of the container? It will be of 16 bits, and then that container will be given a name A, and in that container 95, the value 95 will be stored. That's what it happens when you write something like this. Okay. Okay, then I guess most of the things you learned. Then one few more things are there. Then I'll end the video with a few examples of code and done. Okay, but before that, few more simple things you should know. In a single go you can learn it. The one thing you see, say for example, this RAM. Okay, this RAM. You can think of like, although this RAM is used by different these different programs. Certainly, as I said, no, if you are using Word, then also that program will be using some part of the RAM. You are using, say, this part of the RAM is used by Word. You are using Adobe Photoshop. Then say this part of the RAM is used by that software. And say for example, you are using Paint editor, and that part of the software, I mean, the RAM is used by this Paint. Similarly, you are executing a program p1.c, I mean, not .c, p1.exe, then some part of the RAM will be assigned to p1.exe. You can think it this way. Okay, this is sort of a locality here, p1.exe. So whatever the container this particular program is using, this program doesn't have any direct access to those containers. Whatever the containers this program is using, they do not have any access to the containers used by this program. You can execute multiple programs. Say for example, another one is p2.exe. In that case also, p2 will have a separate sort of area of the RAM where it can create and delete its, or create and destroy its containers. So whatever the containers this p2.exe is using, those containers will not have any effect on the containers of p1.exe. They do not have any access. They do not know anything about the containers of p1.exe. You got the point. Now you can think of, they're like sort of separate homes there. Okay, all of them are like human being living in some house, but the thing is that they are completely separate, and this is a separate family, this is a separate family, the separate family, and all. And stop the analogy there itself. I mean, they are the relatives of they are them. Those concepts doesn't and do not exist here. Okay, but just to tell you that they are independent sort of, okay, from one another. Why I bring this thing? Okay, now see, a program, now whenever you are writing a program, in a program certainly you have to declare a lots of variables, you know that. Now let me tell you this thing. Say for example, you want to create a variable a, so you can create it. So you can think of, in the RAM, in that area, one container will be created, and it will be given a name a. Now see, whatever the variable you create in p1.c, suppose this is your program p1.c, whatever the variable you create in p1.c, all of them will be, like all the container will be created inside the same part of the, of the RAM. It means, they are within the same access in some way. They are within the same family in some way. Okay. Now see, okay, it is okay. Integer a is fine. Now suppose you want to declare another variable. Can you do something like this? Integer a again. What it will try to do is it will try to create another container a in the RAM. It will try to create another container in the RAM and it will try to give it a name a. Now suppose for the time being, assume that this is valid, this is possible. So what will happen when you write a is equal to 9? Now the computer will first go to the RAM, it will check is there a container whose name is A. Now if this is allowed, then it will be seeing, okay, there are two containers there whose names are A. Which one? Where to store this number 9? There will be confusion. Okay, so to get rid of those confusions, what it is not allowed is that you cannot create two variables in the same program. Most of the cases, okay, there are some specific details you need to know, but anyhow, in the same scope, you can rather say that in the same scope, or here I'll be using the term program. In the same program, you cannot use two variables, you cannot give two variables the same name. This thing is not allowed. It is as if like in the same family you have two persons with the same name. See how confusing it will be if two people, they are living in the same house, same house, and then they have, both of them have the same names, and someone calls, say the name is Hari, and someone calls, hi Hari, what's up? Then which Hari will reply? It'll be confusing, no? In case of human, that will certainly, that is not a big confusion, but then also you can think of. But in programming world, certainly this is the confusion which is not tolerable. So for that reason, this is not possible. In when you declare a variable, then these names must be different. So int a you already have done. This thing you cannot write. This is illegal. Okay, this is called as an error in a program. You cannot do that. Got it? You might be thinking, okay, is it then possible? I have integer a already, but now I'm creating a different type of A, float A. Is it possible? No, that will also have the same problem. A is equal to, suppose it is created, and then you write A is equal to 9. Simply you write 9. This 9 could be represented as float also, integer also. So, when you write A equal to 9, what exactly, which A you are talking about? So that confusion will still be there. So for that reason, even if the type of the variable that you are, that you're creating is different, you cannot keep the same name. This is also an error. This is also an error. So the moral of the story is that no two variables, no two containers will have the same name in a program. That's the moral of the story. That is the first rule. And I guess it is quite logical, right? If people will not face any problem to digest this restriction. There are some other few restrictions when you give names to the variable. Say, for example, you just think logically. I'm going to tell you something. Say, for example, you declare a variable int 3. That's not possible. Why it is not possible? See, if you do that, it means in the RAM you're creating a container, you're calling it 3. Now, when you write 3 is equal to 3, you're trying to, see this here it will be a confusion. These symbols, when you write like 3 as it is, like 3 here, these symbols have special meaning. This 3 is a value there. Okay, so these numbers you cannot use to give names to the variables. So this is not allowed. Okay, so the same way it is also not allowed. Integer, it should not start with a digit. Say 3a, it is not a valid variable name. It cannot start with a digit. A variable name can, mostly it will start with letters like a or capital A or Z or something. This is a valid variable name. And maybe underscore, with underscore a, it's a valid variable name. But other than that, like, you cannot start the variable name with a digit like this. Those are some rules that you have to follow. In this, I just wanted to warn you that although you can keep any variable name as you want, when I say any, it is true, say, most of the times. But there are situations where you have to be careful. You cannot simply keep a variable name as int3. That's really not possible, illegal, and that is an error. You cannot create a variable like int3a, okay? Or you cannot keep two variables the same name. These are some basic rules and quite logical, but basic rules you have to remember. Although I didn't say the entire entire rule set, but what I suggest you people to do is you please follow this book if possible along with this video series. Okay, what book it is? Okay, let me Google this. NCC by E. Balaguru Swami. Sorry, E. Balaguru Swami. Yes, right, this book. You see this book, Programming in NCC? This particular book, if you want, you can follow with this video series. Now, this book is written like in very simple language, explaining you all the basic concepts along with all the details also. So, for example, I said there are 32 different keywords. All of them are listed properly here. I said you the meaning of keyword, but I never said you actually what are those 32 keywords there. If you want, certainly I can come up with a different video, but my point was to make you know that okay, there is something called as keywords there, and they, what do they mean actually. There are 32 of them, and I told you about 4, and certainly in the coming videos you'll learn automatically, you'll learn a few more of them. But a complete exhaustive list, if you want, for the preparation of your exam or some other purpose, then certainly you can read this book. And not only that, and what are the things that I said? Okay, say for example the rules of declaring variable. I just said you a few of them, like you cannot keep two variables the same name, you cannot start the name of variable with a digit, and then the variables are case sensitive. That also I said you. So int a, okay, and int a, these are two different variables. So in the same RAM, I mean this is not possible, in the same in a program you can have a container whose name is a, and you also can have a different container whose name is capital A, because like for the compiler, this a is completely different from this a, so it doesn't get confused when you write a equal to 9. It knows that here you want to store 9. When you write a is equal to 90, it knows that there it has to store this 90. So this case sensitivity is another rule. So, but an exhaustive list, if you want, then certainly you can read this book. This is quite a, I mean, if you are starting learning C programming, and seriously, if you want to learn it in a great details with a lots of confidence, then this is one book, then you can start it. Okay, guys, then. So most of the things about variables also I said, okay, now we know the things, right? We know the rules, we know the, how do we do the things and all. But yeah, one thing here I have to tell you again. Now, see, this is another point that comes up right now. I did something like this, integer a comma a. What am I doing is, see, yeah, this is another shortcut actually. So if I want to write, say, int a, one variable, and then I write int, say, b, another variable. Okay, so both these two, these a and b are of types, similar type, so I can combine them together. I can write it in this way, integer a comma b, in this way. Okay, another example, you see. Now I guess we are ready to write code, no? And while writing code, we can see these things in more details, because you now know all these terms. Now, if I say these terms, you will have an idea actually in the mind. Variables, data types, keywords, assignment, declaration, initialization, those sort of things, right? Okay. Okay, then let's write some code. Okay, this is our previous program. So I'll be creating a new file here, and then I'm calling it, say, for example, program 002.c. Although it will not be this program, the task of this program is not to do a specific job, but just to explain you, these different, the concept of variables, okay? But again, whenever you are now declaring variables, the first thing is that it should be inside a program. And first and foremost, whenever you are writing a program, first and foremost, you write the basic skeleton of the program. So has include. Now today also I'm going to do the same promise, like these basic skeleton, I am postponing the explanation for some later videos, okay? Hash includes standard input output dot age, and then you write int main. I'm just typing the basic skeleton, return 0, 0, like that, right? And there Now we want to declare a variable. That is, suppose in our program we want to add two numbers and we have to store the result in a third number. So what we will be doing is we want to store the number 9, say. How we are going to do that? That is, our task is store an integer number. That is our task in the program that we have to do. So for that reason, what is the first thing that we have to do? We have to first create the variable int. Create a container. You can call it anything. For simplicity, I'm calling it A. And then in A, whatever it is the number that you want, you can store it. Done, like that. Or what you can do is you can write like int A is equal to 9, put a semicolon. Now when I write this thing, int A and A equal to 9, int A equal to 9, both these two things cannot be there in the same program. Why it cannot be? Because see, it will create a variable whose name is A. This will also try to create a variable whose name is A. But then also, suppose I try to run this program. Let's see what happens. See, error, redeclaration of A with no linkage, int A equal to 9. I mean, these with no linkage, for the time being, you can omit it. I mean, you can sometimes do redeclaration, but that's a different story. But for the time being, the point is that okay, redeclaration is not possible. I mean, you cannot declare two variables with the same name. Correct? See where this error is occurring in line number 8. See, C8 and 9. In line number 8 and 9, there is this problem. I'm redeclaring the variable. Note, previous declaration of A was here in integer A. Oh, here again in line number 9, I guess. Oh, in 5, there is this problem here, just showing that previous declaration of A was there. But anyhow, the point is that it is getting confused with these two different declaration. I mean, twice you're trying to create a variable whose name is A. For that reason, this error is coming. But if I change this A from A to capital A, now see, the error will be gone. I run the code, and I see there's no output of the program, certainly, because I'm not generating any output. Just okay, then let me write this thing, printf. I want to display this message, say printf at the end of the program, say done. In a new line, say, so I'll be writing it in this way. And then I'm running the code. You can see the program is, sorry, here is a mistake somewhere, printf. Okay, semicolon is missing. See, error, expected semicolon before this return statement. Before this return statement, expected semicolon here. Although it is saying before, it means you're not supposed to put the semicolon here. Okay, you have to put the semicolon after the printf statement. These hints, they are, you just use these error messages only as hints. Sometimes it might not be pinpointing exactly the point. Okay, so you have to. And now see these errors. So whenever you are writing, whenever you start writing codes for the first time, you start writing programs for the first time. It usually happens. Do not worry. It usually happens that you end up with lots of errors, and it happens with most of the people who started learning, in their, first few days at least of writing programs. Okay, it happened with me also. A lots of errors when when you first learn programming. But as days goes by, you will be you'll be learning automatically how to get rid of these errors. Whenever you're typing in the first attempt itself, you don't do those mistakes usually. But then also, for some reason, if you get the error, just by looking at the error message, you'll come to know, okay, that is the problem. That is the mistake that I did in my program. So all these things will happen if you do a certain amount of practice. I don't say a rigorous practice and all. Obviously, if you do that, you will become an expert. But on average, if you do some slight practice, a daily 1 hour, or maybe in a week 3-4 hours, then that will take you to a good position where you will understand most of the things. Okay, having said so, again, I'm like, just again, as I said, no, we have not yet reached the programming part. We'll be writing good programs. But before that, I wanted to give you the background story. I didn't want these videos to be like straightforward. Okay, this is a printf, this is a declaration, this is a assignment. That way, I didn't want to introduce you the concepts. I wanted to introduce you the concepts with some background, things and all, the story and all, the complete picture. Somehow, I'm trying to give you. Okay. Okay, done. Now this is a wrong thing, right? Certainly, right? Int a int. No, this is right thing. I'm sorry. This int a is completely different from this int a, and you know, I mean that's okay, fine. Now another now simple things you can try here, right? See this return zero, always it has to be the last statement of your program. Okay, for some reason you'll know that in the coming part, in the coming videos. And then say for example I want to store 9.5, so I'll be writing float, say s is equal to 9.50. I can write it in this way. Okay, then say for example I want to declare another float variable, say float xz is equal to 0.00098, like that. Okay, or I can declare in the same statement I can declare like, sorry, I can declare float, say h equal to 9.0008, comma, see there is this comma, and then say for example g is equal to 0.00087, semicolon. Now these two lines, if you want to write them together, I mean here what we're doing, we're creating a variable, and we're initializing a variable, float variable s with the value 9.50. Here we are initializing a float variable xz with this value. Here also we are actually declaring, and we are creating two variables, and we're storing some values there. We're doing two initializations, but this is a compact way of writing these two statements. That's all. It is not doing anything else, any new things. Only thing is that if you want to combine these two lines, I mean the two declaration, two initialization at the same time, then you can do that by writing this float h equal to 9. Then you do not put a semicolon. See, if I put a semicolon here, what will happen? See, you know, like semicolon marks the end of a instruction, so it means the sentence is over here. So if the sentence is over, then this G, I mean, to whom it is referring to, sort of, okay? To what it is referring to, what is the type of Z? Got a point? So for that reason here, you do not write a semicolon, you write here a comma, and that comma is a comma. I mean, that is the part of the syntax, okay? It is not that, you know, I am writing it just for clarity. It is not that. It is a mandatory there, okay? It is part of the syntax. I'm not writing this comma for clarity. Okay, here you should realize that. So you can combine these two initialization, but you have to follow these rules. Like, okay, first you have to specify the type, then pair of, you know, assignments, like the name of the variable and then what value you want to store. You can put a comma, and then again you write another pair, and then again you put a comma. If you want, you can write another pair. Say for example u is equal to 90, like that. So now see, you should realize all these, the type of all these three variables will be always float. You cannot combine one float and one integer together. Certainly, if you try, you'll not come up with any idea. I mean, how do you do that? No, a float and an integer together. In this way, certainly it is not possible, right? Okay. See, you can combine multiple initialization at the same time, or if you want, you can simply combine multiple declarations. Say, for example, you know, h1, j1, iol90. I'm just writing some variable names here, okay, just to show you that variable names could be as you know, like as confusing as this also. Okay, so here I'm like declaring three different variables. I have not initialized those variables with any value, just I have declared, I just have created the containers. I didn't store anything here, but here I created the container, and at the same time I stored some values also there. Okay, so now see, we got the point. Now what is the point? See, if you have followed the video, then what you will be able to understand is that what does this mean. Now whenever you are seeing in a program like you know, int a, you immediately know, okay, this is just creating a, you know, this particular instruction is creating a container. This instruction is, you know, storing a number inside this. Now how this program will be executed, let me you know, I'll finish the video like within 5-10 minutes, I guess. Okay, like the final thing, let me show you how this particular program will be, you know, executed by the computer. Which program I'm talking about? I'm talking about this program. Let me copy this program, okay, to this notepad, so that I do not have to come here again and again. I'm not sure whether I'll be able to type things here on the top of it. Yeah, I can. That's a good news, right? But can I make it big? Can I? There should be, yes. where I make it heading 1 before. Yep, right. Okay, now see how this program will be executed, in terms of the things that we already learned. When you execute a program, you should realize that the program will be executed from top to bottom, one instruction at a time. This is an instruction, okay? I mean, in some way, this is these asks the it does a specific thing actually, okay? So first, whatever it is, the specific task represented by this particular line, that will be done. I have not said anything about like what this line will do, but certainly it is doing something, and whatever it is, first that part will be done, and then it will come to this point. Then this is your next line, and this line represents an something, some special thing to the computer, like int. You have seen it. It is a data type, isn't it? Why have I written here? It is not a declaration. Then why have I written here this data type? Yes, these data types we use not only in declaration, at some other places also, but you will come to know about it in the coming videos. So you can think of your program actually starts from, like, always your program gets executed from this point, like wherever this main. Now this main is not a keyword, it is not a inbuilt function, nothing. It is just a user defined name, but the thing is important, or the special thing, or the like the peculiar thing about this main is that in any C program you write, this main function must be there. This main function must be there. Okay, so whatever it is the program that you are writing, there should be exactly one main function in the program. And whenever you are executing a program, your program will start executing from the beginning of the main function to the end of the function. It means whenever you are executing this program, it'll start executing the program from the first line, or from the first instruction that you have written. Now, in the first line in my code, I have written it in this way, like / store an integer number. Now, I didn't say you, but these are called as comments. Like whenever a line is started with these two forward slashes, they are called as a comment. In the sense, what are comments? Like comments are something. This is a simple concept. Okay, comments are like not part of the program, not part of the program. Okay, so whenever you are writing two forward slash and then whatever you write, that line will not be considered as the part of the program. What I mean is that if you write a program and then something is there in the comment, said something something, and then you have this int a and all, say that program, it will go through this compiler and then it will generate the machine code, right? So when it goes to the compiler will ignore all these comments. It will just assume that whatever you have written as a comment, those lines never exist in the program. They are not part of the program. They are only to see, since you why do we use comment? We use comments for human reader, the programmer. So if you write a program today, so you write something in comments, so that later on if you see the program, you remember, okay, why you wrote something the way you wrote. Comments are quite useful, but they are only for human, not for the program. That you understood, I guess, right? Okay, now let's actually come to the point now. What happens when this particular program is executed? So let me copy and paste it fresh so that I can start now, because I didn't tell you these basic things. I mean, the starting always starts with main, and what are these comments? But now you know, right? The program always starts from main, and these are comments. So those are not part of the program. Okay, once you know that, you are now ready to see how this program is executed. So you know from where the program will be executed, from here, from this starting flower bracket till the end flower bracket. Now the control, that is the program, will be executed one instruction at a time. So certainly this is not an instruction, because this is a comment. So this particular instruction will be executed when the program executes. This instruction will be executed first. So you know what that instruction does. It creates in a container in the RAM, and it is called as A. And then once this instruction is over, once this container is created, okay, the task specified by the instruction is done, then it will go to the next instruction. The computer will execute the next instruction. There you have written A is equal to 9. So A is equal to 9 means 9 will be stored in this variable. Then you have written float s is equal to this. So this instruction will be executed. Once this is done, then it will go and it will execute this particular instruction. Float s is equal to 9.50. So what will happen? In the RAM somewhere, some 32 bits will be allocated, and those 32 bits will be called by the name s. And then in that variable or in that container, in those 32 bits, the binary representation of 9.50 will be stored. Got it? Then float x. Now, once this instruction is over, then you are writing float xz is equal to this. So when you write float xz is equal to this, it means it will create a container of 32 bits, and then it will store there 0.000 whatever it is 98. Similarly, this instruction. Now, once this instruction is over, it will execute this instruction. Float h is this, z is this, u is this. In the same instruction will create three containers. One is h, where it will store 32 bits because your type is float, where it will store 9.0008. It will create another one z. It will store some value there, 0.00087. It will create another one u, and will store this number 90. So since you declared this as float, it will be stored as 90.0. Okay, although you have written 90, but internally it will be stored as 90.0. Okay, same way this float. Now this instruction. Once this instruction is over, now the next instruction is this. So it will create. Now see what is the difference between these and this. These instruction will also create three containers. One will be h1, but it will not store any specific data in this container. Okay, it will create another container j1, but it will not store any specific data in this container. It will create another container i0, I capital, I guess, in 90 or something like this. Okay, and it will not store any specific value there. And then you are writing int a equal to 9, so it will create a container a, it will store a 9 there. Then printf done. So now it will not do anything in the RAM, but it will now, the program will now access the display, the monitor, the display, and there it will print wherever the cursor will initially start blinking here. So it is new line, so that it will come to this point, and then it will display from there DONE, and at the end the cursor will blink here, and then return 0. It marks the end of the program, so that way the program will be over, and then you will get this prompt back. So what this program will do, yes, it will create a lots of variables in the RAM, but that's all. We'll not be able to see. Certainly we cannot get into the RAM and then we can see these values there, right? Yeah, but my point in this video was to show you, like, to make you people comfortable with with code that looks something like this. Now if you see codes like this, at least this part or something like this, if you see, you will be quite comfortable. No, you will be feeling like, okay, I know exactly what is happening there. Correct? So that was my goal. Now, and your next question is quite obvious. Yes. Now, what if we want to see now what is there in A on the screen? If it is 9, then I want to see, okay, 9 is there on the screen. I mean, I want to see 9 here. What if it means, like, if we want to display the content of a variable on the screen? Till now we know like how to display directly a string. If we have to display done, we know how to display done on the screen. But what if we want to display the value of this variable a on the screen? What if we want to display the value of this variable u on the screen? What if we want to display the variable I0190 on the screen? Those things we'll be learning in the next part of the video. Those are very important things, and you can think of like the next part of the video will be sort of a follow-on video of this part of the video. So I request you people not to skip. So for that reason, please stay tuned. Yeah, you can subscribe this channel. That way, as soon as I upload the video, you'll come to know, okay, the video is uploaded. And yeah, that's all then, guys. Okay, that much only I wanted to tell you people in this part of the video. See you guys with some new content in the next part of the video. Till then, have a nice day.